Okay, let's start. I'm Zhang from Intel Open Source Technology Center. And here I'd like to say something about the 5-level paging in Zen. Okay. So first, I'd like to give a summary of the current architecture of Intel x64, and I'd like to explain why do we need 5-level paging, and also a brief introduction of 5-level paging. After that, and give a brief overview of Zen design considerations of 5-level paging. And first, we know that Intel x86, which is also known as IA32E, has been around for more than a decade. And almost every modern operating system supports this paging mode. Although 64-bit is linear address, but only the least lower 48-bit really counts when the memory address translation happens. That means the linear address space addressable would be 256 TB. As to the physical memory address, currently existing Intel processors limit the maximum value of this width to 46-bit at most, which means the biggest physical address space is 60 and 64 TB. Whereas to the memory size concerned, 64 TB is a pretty big value. But we are also hearing voices from industry requiring even more bigger memory size for the future requirement. For example, there are quite a lot requirement for the database, which is aggressively moving to the in-memory database. And we also see some huge large-scale systems, which is shipping platforms which has reaching the limit of 64 TB memory size. And also, as you may know, that Intel has and Micron has announced a new non-volatile memory technology, which is 3D crosspoint. And if you see from the right side of this feature, you can see the 3D crosspoint memory is between the DRAM and the NAND SSD. It is considerably faster than NAND, and it is more endurable than NAND. And it is denser than DRAM and with lower cost. So two-level system memories based on DRAM and 3D crosspoint will give us a future that enables the physical memory size with a huge size and probably bigger than 64 TB. And from the software point of view, most modern operating systems require 2 more linear address bits than the physical ones. 1 extra bit is needed to provide the split between the user space and the kernel space. And another extra bit is needed to map the whole physical address space into the kernel linear address space. So that we do not have to face the low high memory issue which existed in the 32-bit era. So as a conclusion, with physical memory size greater than 64-bit being foreseeable, we may have to enable a linear address width greater than 48-bit. And that means 4-level paging would be not enough by then. So this is an overview of the 5-level paging, and as you can see, it is also named as LA57, which extends the linear address space width from 48 to 57. And as to the physical address size, although Intel specs says that the maximum physical Intel spec says that the physical address in paging structure entry can use 52-bit, but in fact only 46-bit are used at most in existing processors. But with parallel paging, the physical address in the paging structure entry can really be extended to up to 52 on processors which have parallel paging. And with the extended linear address width comes a new canonical requirement. As you can see from this figure, that in the 48-bit era, we have 40-bit canonical, and an address is considered as canonical when the bit 64 to bit 47 are either all cleared or all set, will be considered as canonical. Otherwise, they are non-canonical addresses. Translations for these non-canonical addresses will cause GP fault or SS fault. And with 57-bit linear address width, the canonical requirement will be a new one, which is 57-bit canonical. It means that address is considered to be canonical when the bit 64 to bit 56 are either all cleared or all set. And as you can notice that a 57-bit canonical address might be a 48 non-canonical one. So we need to take extra care for this part. And another trickier part is that with parallel paging, a new canonical checking mode is introduced, which is the CPU canonicality. That means an address is considered as canonical as long as this address follows the maximum linear address supported by the real CPU. So even it is running in for-level paging mode, an address can be considered as canonical for this part. So this CPU canonicality requirement is mostly for some special register loads. And for the paging mode, canonicality is mostly required for the memory translation process. And with the wider physical address width, hypervisor, for example, need to take extra caution when trying to traverse the guest page table. We need to check a new reserved bit mask. And also comes a new EPT mode, which is 5-level EPT. And it should have other impacts such as LMMU when the guest physical address is extended. And I can say there will be more features that would be influenced by the extended physical address, but I cannot see that feature. Okay, this is a figure showing that the 5-level paging translation. As you can see, it's quite straightforward extension of the 4-level paging, just adding another level of paging structure on top of the 4-level paging. And the entry of PML5 has the identical structure as PML4 entries. So enable the 5-level paging in Zhang means that we need to provide support of 5-level paging to HVM. And we need to provide 5-level paging in Zhang. And we may need to deal with PV guests And we also need to consider, for example, whether we need to support that in shadow. But the easiest part, which is most straightforward one, is we provide the 5-level paging enabling for HVM. So we just expose the LA57 feature to HVM with the CPU ID enumeration, and we can extend the guest page table traversing logic, and in hypervisor, we can introduce a two-stack configurable parameter, which is the maximum physical address exposed to the guest. I mean, only when the guest is exposed with a maximum physical address greater than 48 will the hypervisor choose to use 5-level EPT. So, I mean, even if the guest is running with 5-level paging, as long as its guest physical address width is smaller than 48, we can still try to use the 4-level EPT. So that we don't need to worry about the performance downgrade.
Okay, we're at time now.
Okay. And for the 5-level paging support in Zhang, it's much more complicated. We have many difficulties. Here I just list some of them. One is that, for example, if we want to introduce 5-level paging, we need to modify some definitions, but the definitions are used in the idle page table construction, which is constructed at build time. So it's hard for us to introduce a new definition for these values without moving this construction of page table into dynamic building. Also, for the 5-level paging support in PV domain, it is still controversial if it is worthy if we consider the PVH domain 0 status. Also, we might need to provide the paging mode switch for example, to support the UEFI boot. But paging mode switch would be painful. And other options like shadow mode support. And I have heard different voices from community on whether or not we should support 5-level paging in shadow. So here my proposal is we provide a basic enabling to put them in 5-level paging first. And we can consider to add new enhancements step by step. So for the basic enabling, we can provide a logic to support a new paging mode with a separate binary. And I mean, we can introduce some configurations and which limit the hypervisor only support 5-level paging. But we also need to consider moving the paging mode construction, paging structure construction into runtime so that we can at least support 4-level paging and 5-level paging in one binary. Also, I'm considering to fabricate a 4-level of paging mode to PV domains. That means by fabricating, it means the PV domain is running in 5-level paging, in fact, but it is cheated to be running in 4-level paging mode.
Okay, we're now 5 minutes over almost, so
okay.
We need to wrap this up.
So also we can compare out the shadow paging at the first stage, and we can provide support for shadow, 5-level shadow if necessary. And so for the future enhancement, we can support some other impacted features. For example, as LMMU, and we need to support the runtime paging mode switch. And we may need to provide support for 5-level paging in shadow. And whether or not to support 5-level paging in PV, I think it depends on the status of PVH domain 0. We will have a discussion session this afternoon, and you're welcome to share your insights. And that's all.
Okay, thank you. I think we better move straight on now.
Okay, sorry, I don't have time to answer questions. That's all. Thank you.